Okay, so look at this question 4. They said use Newton-Raphson method. So Newton-Raphson method by taking X note. Sometimes they will give us X1. Sometimes they will say initial value X1, initial value X note. So it doesn't matter. They want to start with X0 or X1. We follow the questions. Okay. So initial value is 0.6. Okay, so initial value 0.6. Then Newton-Raphson method. Okay, they are testing us on Newton-Raphson method. Then they say find the estimate root. So means you have to find out what is our x, what's our solution for this equation. For this equation, correct to 3 decimal place. So final answer 3 decimal place. So in the middle, when we want to calculate, our calculation must be extra 2. At once 2 decimal. So we will use 5 decimal in our calculation. Okay, maximum is extra 2 or extra 1. Depends on, normally we use extra 2. Okay, so for Newton-Raphson method, first we have to find out what is our function. This is equation, okay? This is equation, not yet function, but when this equation equals to 0, we can assume this equation is a function already. It's a cubic function. Okay, so it's a cubic function, it's a polynomial function. Then, from our function, we're going to differentiate. Power turun depan, power tolak 1, power turun depan, power tolak 1, then differentiate nombor dapat kosong. So, Newton-Raphson method formula. If you want to find the next n, you have to substitute the original n, then minus, substitute the n into the function, then substitute the x into the f prime, substitute the x into the s prime x function, differential function. Okay, so this is Newton-Raphson method. So from here, our initial value, so they give us a starting value already. So which is x, initial value x0 is 0.6 minus, okay, so we're going to start with our value 0.6, substitute into our function. So for this step, we have to write the working in fully. So as the value 0.6 substitute into the function, and then at the denominator will be our differential function. Okay, so write this step fully. Then how we going to press our calculator? So refer to your calculator. We will key in our formula. Key in our formula. It will be, our formula is alpha x minus, okay, alpha x minus function. Function is this x cubed. Alpha x cubed minus 3 alpha x squared, then plus 1, then next go to denominator, differential function 3 alpha x squared, then minus 6 alpha x. Okay, so we'll key in formula, then we press calculate. We press our calculate, then we calculate our x value, which is 0.6. Okay, calculate for 0.6 equal, once again, okay, when the answer come out in fraction, we don't want. This topic is talking about decimal, okay, talking about decimal, so change it to decimal. Our answer here we're getting 0.6. Okay, so just now final answer is 3 decimal, so in our working extra 2, 653, then 968. So 968, 8 is more than 5, so you have to round off, become 97. Okay, so after we get this value, we're going to substitute again to find the next x. So it will become, the next x will be x1 lah. Okay, so we substitute this new x value minus. So for this second step, we can write it in short. We can write in terms of fx like this, 0.6597, then differential function. So what's the answer? So we just calculate one more time. Okay, what is the value? 0.653997. Okay, so plus exactly what do you want to substitute here? Then equal. Okay, so we take down the answer 0.527042. 42, so no need to round off. Okay, 407, no need to round off. So it will become 70 lah. Then continue. So for the next step, next. So for the first step, write the working in full. Second step, you can short writing in fx, f prime x. So for the remaining, after that remaining, you don't need to write. You just take down the answer already. So we repeat this calculation process. Calculate for 0.6527, that equal. So we get this 0.65270. Yes, repeated. Once repeated means this is our x value. So conclusion, our x value will be round off to the 3 decimal place. So this is 6527. So you have to round off, become 3. So this will be our roots. This is our root by using Newton-Raphson method. So this is how we perform our Newton-Raphson method. And then we have one way to check our answer, whether this answer correct or not. So we have to clear this first. We press our equation. We key in our equation here, alpha x cubed, and then minus 3 alpha x squared, and then plus 1. So that equal is at here. Shift alpha, calculate this one, equal 0. Okay, we key in the whole equation here. Then estimate the roots means you are using the option here, function here, shift for solve. Okay, so just this one, just ignore this. This one is memory before it, just equal. And then they will help you to calculate. If you want to solve this, your x value is this. Left hand side, right hand side, no error. So 0.6527. Yes, see our answer is exactly. So means we double check. Yeah, we are doing correctly by using this Newton-Raphson method.